In this video, we will talk about the Cartesian product. So let's start with the definition. Let S and T be sets. We say the Cartesian product of S and T is the following set. So the way I read this is I say that, well, the things inside of the set are ordered pairs. Written in parentheses, there's an S and there's a T here. The S is an element of the first set, capital S, and T is an element of the second set, capital T. So these are ordered pairs. Ordered pairs. Okay, and the way to denote the Cartesian product is we write S cross T. So it kind of looks like a multiplication symbol. So let's do an example. I'm going to let S be the set with A, comma, B, comma, C, those three elements, and T be the set with 1 and 2 in it. Write the Cartesian product of S and T in our set roster notation. So I'm going to write curly brackets to indicate I have my set. So the elements of this Cartesian product are these ordered pairs, where the thing that goes in the first spot is something from S, and what goes in the second spot is something from T. So for example, I could have A first, and then I could have a 1 second. Also, if I had A first, I could have had 2 second. Okay, now I have all the possible things where A is first. Well, let's do all the things where B could be first, like B comma 1 or B comma 2. And then the things where C is first, like C comma 1 and C comma 2. And now I have all these ordered pairs. So notice that the cardinality of this, the number of elements of my Cartesian product, are the number of ordered pairs that we have here, which is 6. I could systematically count that as, well, for this first element, there were 3 choices, A, B, or C. For the second element, there were 2 choices, either 1 or 2. And I multiply them together to get 6. So more generally, we have the theorem which says if the first set has n elements and the second set has m elements, then the Cartesian product will have n times m elements. So let's end the video with an example of a common Cartesian product. So I can even take more than just 2 of these things and do a Cartesian product of them like we have here. Here we have 3 of these things. So each of my sets is R, the real numbers. So now we're talking about ordered triples. There are 3 of these things that go into this, where each one is an element of R because each of these sets here is R. So the shorthand way to denote this, instead of writing R cross R cross R, is to write R and then a 3 up here, kind of where the exponent is. Although it doesn't really mean exponent, it just means ordered triples like this. I could similarly define this thing for other values of n. So for example, one element of R3 would be, maybe I have 1 first, because that's a real number, and then maybe I have 7.2 next, and maybe I have pi next. That would be an example of R3. It's a tuple that has 3 elements, and each one of those elements is a real number, so it's an element of R3.